Question is given, which one of the following sets is countable? जहाँ भी सेट दिखाई ए सेट मानक मध्य कौ सेटा कौन हम काउंटेबल सेट ओके मीन्स एमाने जो सेट देइचंती सेट मानकर कार्डिनलिटी कौन हम एप्सिलॉन नॉट ओके and first option is given the set of all real numbers, and we know the set of all real numbers is r equal to q union q complement. Q is set of rational number union the set of irrational number, and we know set of irrational number is uncountable. Okay, uncountable means its cardinality is continuum c 2 to the power epsilon not equal to c. Okay, then if this is uncountable and this is countable, then r will be what? R will be uncountable. So this cannot be countable set. Also the option D, the set of all irrational number also can't be what? Countable set. Okay, then next come to the option B and C. Option B, the set of all algebraic numbers and the set of all transcendental numbers. Okay, if you know what is transcendental and algebraic number is okay. If you don't know, I will tell what is algebraic number. Algebraic number are those numbers which can be expressed. This is those numbers which are solution of a polynomial with integer coefficients. Okay, those numbers are said to be what? Algebraic number if there exists an polynomial with what? Integer coefficient. With integer coefficient, then that number is the solution of the polynomial, then that number is said to be algebraic number. And which one is not algebraic number, that is called transcendental number. Okay, and here to note that the set of all algebraic number is countable set, and the set of all transcendental numbers are uncountable sets. बुझेला? So here what will be? The set of all transcendental numbers are uncountable. So this is not countable, and this is the correct option, the set of all algebraic numbers. Okay. The next question is, consider the following statements with regard to the matrices D1 and D2 and a non-empty set X. Okay, here is given two different operations, that is D1, D equal to maximum of D1 and D2 is a matrix space. Given these two statements are what? True or not, we have to check. We have to check what? We have to check D and Ci, these two are what? Either metric or not, is not metric on X. Okay, we know if D is metric, that means what? If D is metric, then D of xy greater than equal to 0 for all xy. Okay, this is what? This is called positive definite. Then D of xy equal to D of yx. Then also D satisfy what? Triangle inequality. D of xy less than equal to D of xz and D of plus D of zy. Okay, so first we will prove for first one, D equal to maximum of D1 and D1 D2. Maximum of D1 and D2 is a metric or not. So what will we do? Here D is given max of D1 and D2, and here we know D1 and D2 are what? Matrices on X. Okay, so clearly D of xy greater than equal to 0, because as D1 is greater than equal to 0 and D2 is greater than equal to, then their maximum is clearly greater than equal to 0. That means D of xy is greater than equal to 0. Then next come to the next property. What is given? D of xy. We know D of xy equal to maximum D1 and D2, and here D of xy we can write D1 of yx and D2 of yx, because D1 and D2 are metric. So D1 of xy is equal to D1 of yz. So in that place I wrote this, and that place I wrote this. Then the maximum will be D of yx. Okay, you can clearly see the definition by I just used definition here. Okay, then next come the triangle inequality. D of xy equal to, we know max of d1 xy d2 xy. Okay, and d1, as d1 is what, metric space, metric, so d1 of xy greater than equal to d of xz plus d of zy. So I just greater than, thus I written greater than equal to max of this and max of this. And if we will write, and then you can clearly see, you can just check what I read, what I have written, this is right or not. You can just check. Okay, what max of d1 xz or d2 xz maximum plus etiki will be greater than this, and this is what d of xz and this is what d of zy. Okay, here the three properties, D satisfied all three properties. So what is D is metric on X. Okay, next see this psi. Psi is minimum of d1 and d2. Okay, this will not be metric, so I will basically focus on the triangle inequality, because other two are very easily you can check these two properties satisfies psi. Okay, so I directly come to psi of xy triangle inequality. So I just written what is it given psi of x1, then you can see, as d1 and d2 are what, metric, so d1 of xy is greater than equal to d1 of xz plus d2 of d1 of zy. So I just written that and I has given less than equal to, hala? Then you can clearly check, if we will take minimum of this and this plus minimum of this and this, then this will not be less than, that sometime may be less than and sometime may be greater than and sometime may be equal to. So this is not always true. So that means the triangle equality does not always hold. That means psi does not satisfy triangle inequality. So psi is what? Psi is not metric on X. Okay.